Hey everyone, so today we are doing a mock for Google interviews. So this is exactly like a similar to Google. I try to keep the bar similar to Google. And over here, like we are also following the pattern of Google. We are using a Google Doc, which usually Google uses during the interview. And they do not expect running code, but actually you'll have to do a dry run on your own, whatever the code that you write. So over here it is entirely unscripted and candidate doesn't know like what kind of questions are going to be asked. Follow this mock interview, certainly like you'll get a lot of learnings, and the way the communication, the problem solving skills, and the kind of approach and the kind of dry run techniques that this guy is applying over here for verifying the code quality which he is trying to maintain over here. Certainly this will give you a lot of learnings, and be sure to check out the feedback at the end. That will surely help you out. So without any wait, let's get started.
Okay, so you got the link, right? Can we
Yes,
jump to the next page?
yes. I'm at the bottom.
Okay.
Yeah.
So today again, like we'll be solving two problems, right? And again, like we'll be doing the exactly similar coding of both the problems, right?
Okay.
Yeah. So before start, okay, you are having water. Oh, it's fine.
Yeah, I'm good. I'm good.
Okay, so let's assume like there is some kind of a lock, okay, which has like four wheels, okay. So and wheels
Mm-hmm.
has some kind of a numbering like 0, 1, 2 till 9, right? For each wheels there are
Mm-hmm.
numbering, right? And
Mm-hmm.
each wheel either you can rotate like clockwise or anti-clockwise, okay.
Mm-hmm.
So for example, like if you are at 7, either you go to 8 or you can come to 6, right? Now,
Yep.
so you will have to start from 0, 0, 0, 0. You have four wheels, right? So there are four, starting point is 0, 0, 0, 0, right? And you have to reach
Mm-hmm.
to a particular target, okay? In minimum number of total number of turns required, okay? But over here, let's say like from 0, 0, 0, 0, you may reach to 0, 0, 0, 1, right?
Mm-hmm.
Right? Or like you may reach to 0, 0, 0, 9, right?
Mm-hmm.
So a move forward or backward. But the problem is there are some dead ends given. Okay. So dead ends means if you reach to the dead end, then you cannot move forward, right?
Okay.
So the problem is you have to figure out the minimum number of turns required to reach to the target starting from 0, 0, 0, 0, right? So let me give you an example, or maybe like you can read through this entire problem statement. I am pasting over here. Okay.
Mm-hmm.
Yeah.
So how come the first turn starts at the end? So like how come it's 0009 and or
Mhm.
1 and not 1000 or
No,
nine zero
it
zero
can be
zero?
that also. Like if you're rotating the last wheel, then it's like 0001. So
Oh,
like
I
you have
see.
four wheels, you can rotate any wheel, right?
I see. Um, okay. One moment.
Mhm.
And okay, so you can rotate any of the any lock uh
Any wheel.
without like regard. So you can have 0100, right?
Yes.
And can you have 0200?
0200. Yeah. So one time, like you can rotate only one position ahead, like from 0 to 1 only. If you can have like a 0200 as well, because you rotated the second one twice, 0 to 1 and then 1 to
Okay.
2.
Yeah. Um okay. So you're given
Mhm.
uh so you are given a target um and you try to see if you can rotate to that target with a minimum number of rotations.
Minimum number of
Is
turns.
that
Yes.
correct? Yes. So for the current example, you start with 000 and the target is 0009. So you can just turn the last wheel once backwards and then uh you get to the target.
Exactly.
I see. Um, if we change this into here, and then 0009 is a deadlock. So the answer would now be 8, where you start rotating forwards because you cannot rotate backwards. Is that correct?
Yes.
So output would be 8 because you cannot go to 0009 and then go to 008.
Exactly. Yes.
Oh, sorry. That's the incorrect. Here we go. So, okay. Is that okay? Um, so you're given a set of deadlocks, and you cannot achieve it. So in the case,
Mhm.
is it always guaranteed there is a way to reach the solution then?
No. So if you are not in the last statement, it's written if you are not able to reach, then return -1 if it is not
Oh,
possible.
right. Sorry, that's true. Right. I didn't see that part. Okay. So if you can't get to the solution, then you return -1. Okay. Um, okay, I understand the question, and it's just either forward rotation or backward rotation.
Yeah.
Um, maybe then I am thinking of a sort of a brute force approach.
Mhm.
So you just start with each wheel. So we start with 0, 0,
Mhm.
and let's say your target is, let's say, 009. Then you just trying to turn each wheel until you get it correctly. So the first one you match, second one match, third one match, and then the last one doesn't match,
Mhm.
and you would either uh either rotate forward or backward. So I'm thinking how you decide whether to rotate forward or backward. Um, you can probably I think you can just simply use a
Mhm.
the uh the the difference between the current value so the difference between a current value and 10 minus the difference. So currently is 9. Currently the difference between 9 and 0 is um hold on, let me see. Um actually no, you know, maybe we would just try rotating forward and then rotating backward and see
Okay.
if we can reach it. So if we try rotating forward, so you would get like 1, 2, 3, 4, 5, and then until you reach 8, and then oh sorry 8, and then we get the solution. Or we also try backwards 9, 8. The reason why we want to do that is is such that if we reach a deadlock, then we would just skip this. We make sure we don't continue. That's a way to check if we reach a deadlock or not.
Okay.
And you cannot jump anything. So this is sort of a brute force approach, but it does not guarantee a optimum solution.
But yeah, minimum actually, how are you guaranteeing over here?
Yeah, I'm thinking how to actually guarantee that. So, so minimum. The only what guarantees what the problem here is that we need to avoid the dead ends, which would which would not which if there's no dead ends, then we will always guarantee this will always be guaranteed optimum solution, pretty much because you're just rotating each logs in the shortest distance.
Yeah.
But the reason why we need to well, then the idea is to avoid dead ends. Let me see how I should do that. One sec.
So over here, you are creating some kind of a path, right? Starting from 0, 0, 0, 0, and you want to reach to the target, right?
Yes.
So the thing is like you have to return some kind of a shortest path, right?
Yep. Shortest path. So let's see. If we have if we start from 0, 0, 0, then we would I'm just thinking how to avoid dead ends here. So I can't think of any specific ways
No,
to
you don't need to avoid, right? One, if you hit a dead end, meaning like you cannot move forward, you can just don't follow that path, right? Just return from that path.
I see.
You are not required to
In
avoid,
this
right? Even though like you hit it, it's fine. Like you cannot move forward, so there you don't have a solution.
okay. Okay. I said, okay, I got the, so I have an idea of how to solve it. So let's say we start with 0, 0, 0, and we have we want to reach to something like this, 0, 2, 0, 8. And we would go through we will loop through our current configuration, and for each one we don't match, we would move to the we would either go backward. We will either rotate the wheel forward or backwards and create two different configurations. And we will also be placing it in a queue in a way, in such that we can keep track of the shortest distance. Okay, so here, and also we can also check whether we hit a dead end or not. So first one, 0 and 0 match, so we move to the next one. And 0 and 2 doesn't match, so we add a new configuration, which is 0, 1, 0, 1, 0, 8. And then we also try the different configuration, which we would rotate backwards, 0, 9, 0, 8. And then we move to the last digit, and then we try the same thing again, 0, 0, 0, 1, and then 0, 0, 0. Oh, sorry, this is supposed to be a 2. So this is a 2. And then 0, 0, 0, 9. And then we would also keep track of the rotation we've did.
Okay.
Actually, we don't even need that. We can just run it in. We can just run it breath by breath. So each layer. This is my so this is layer 2, layer 1.
Yes.
Which means that we did one rotation. And then now for layer 2, we would iterate through a queue, and we create a new queue, and we would do repeat the same thing until we match So we have for the first one we have 0, 2, 0, 1. Sorry, 0, 2, 0, 8. Sorry, and then also we try backwards. Oh wait, no, we don't have to try. Sorry, why did I just put 8 right there? this is supposed to be 0.
Yeah.
I was probably
Yeah, I got your
looking
idea.
at the wrong.
It's fine.
Yeah,
I
yeah,
think
I'm sorry.
it's going to work. So can you tell me like what is the complexity that you will be getting over here?
So this would be a in the worst case scenario, every number we would create, we will have to rotate either backwards and forward. So that is two, in some sense, two branches of the same node. So the time complexity here, the worst case scenario will be 2 to the power of n, because we will be if every number is not the same, then we will have to rotate backwards and forward, which could create one branch, and then we try the next value, we create rotate forward and backwards. So that would be 2 to the power of n.
But what is n over here?
Huh?
What is n over here?
N will be 4 here.
N will be
4, because there's 4 digits here.
so you are saying like 2 to the power 4.
Oh wait, no. Let's see. Let's see. That doesn't sound right. Not to the power 4. That's so for each digit we would create a new configuration. So we would not just in this case it's not 2. Oh, sorry, 10 to the power 4. 10 to the power 4. I think that makes more sense.
Yeah. So for each digit, like you can have 10 configurations.
Yeah.
So at max is like total number of configuration is 10 to the power 4, right?
Yes.
So yeah, that makes sense, but it will be a little less. The reason is like at one point is you are doing a bidirectional BFS, right? It's like from 0 you are moving to 1 as well as 9, right? So that will be a little less, but still it will be in order of 10 power 4. Yeah, still fine.
The time complexity is the same, because I mean there's some solution that will reach faster, so in a sense it's possible to be faster, but then the worst case scenario is still it's probably divided by 2 actually, because assuming because you only have to rotate at most 5 turns to reach a solution, assuming there's no dead ends, because if it's just either negative 9876 or like 1 2 3 4 to reach like the center or something like that.
Yeah. Oh,
so
let's write the code. Okay.
Okay, so we're first start with Q, which would have only 0, which we have 0 0 0. Let's keep making it an array so it will be easy. Okay, that's how we initialize it, and the current layer is 0 rotation. Let's call that rotations. Turns, even better. So turns will be 0, meaning that we have not turned anything yet. So we will have while true. So while we have not found the solution yet. Actually, let's call that found, which is initially false. Found. Well, not found. And we would rotate. We would turn every time we finish iterating Q. So for we have a new Q, which is empty array. For combination in Q, for each individual combination, and for digit in combination, we want to either turn if they do not match, if the digits do not match, then we want to either turn it or let's use I actually, I and V, I and digit, so that I can have the index as well. So for digit, if the digit is not the same as the digit that of the target, also need to find my target. Let's say target is something. Let's do 001. If target of I is same as digit, then we just pass. We skip it. Otherwise, we have to rotate either backwards or forwards. Then if we rotate backward and forward, so Q is dot append the new combination, which is everything before the current combination. Oops, before the combination plus digit either I. Okay, that's going up, but I have to find I have to make sure it is not going overboard, so I have to modulo it, which is by 10 plus everything afterwards. So it will be combination from I plus 1 after. Okay. And then we will do the same for -1, so it's going backwards. Yes. So if we have 0, if we rotate backwards, which is -1, oh wait, if that modularized by 10, it would be, is that -1 modularized by 10? That would be 9. Yeah. Yep. I want just need to make sure because reverse negative modulo is like the sort of the opposite of it. Okay, so now we have a new Q. So okay, now that we've finished with this combination, we just need to oh wait, we need a base case too. Oh, and the deadlock. If combination is equal to is inside of that end, then we continue. We skip. If combination is equal to target, then found is equal to true. Or you know what? Let's just return the turns in this case, so that we don't even need any specific. We don't need to we don't need a condition for the while loop. Oh wait, no, we do need it because in the case that we cannot reach the solution, otherwise, then we run into an issue where we would we run into issue of infinite loop. So you know what, while Q, that would be the best solution to do this. And if we do not reach a solution, we return -1, and we need to assign Q to new Q, which would update our current Q. Let's see if I got this correct. For each item, for each item on Q, we would either check the current combination is a dead end. If it is, then we would skip and not check. We would not check it. Otherwise, we would oh, I forgot to add one thing. I forgot to increment turn every time. Yep. And then we check. And then we would check even if it's the same as target, if it is the same as target, then we return turns, which is the number of turns we made to reach there. Initially is 0. If it's all 0, 0, 0s, then we turn 0, meaning we make no turns. Okay, which is correct. For I and digit inside of enumerate the combination, which is the current, which we will iterate each digit. If they are the same as the target, then there would be no rotation needed. Otherwise, we would either turn up the digit, which is increment by 1. So if we have an edge case of digit 9, we modularize it, then it would be 10. I need to make a little, and we need to make it as an array because I am adding them as array. So in the case of 0, if I get 0, then it'll be rotating it would be 9. So modularized by 10 would fix that. And then combination I plus 1, which is all the digits afterwards and not including I, which is the current digit. Okay, and after we're done, we would append new queue into the old queue so that this while loop will continue running until we find solution. And if we loop through all the queues and we loop through the queue and we still not find a solution, I still run into the issue of an infinite loop in this case.
Yeah.
Do I? Due to the fact that
Do you really think that it will go to infinite loop?
let me see. If I'm thinking of let's say a simple dead end case with 0001. Let's say my target is 002, and I have dead end of let's say dead end is a is a set. Let's just say the dead end is 0001 and then a 0003. So I would try to, yeah, I think I might actually still run into the issue of, yes, I do. I will run into infinite loop in this case still, even if the solution is not found, because on this we would be seeing the same values again, for sure. So I need to make sure I don't go past the same value because we would try either rotating forward and backwards, and there will be cases where they just keep
Right.
rotating forward and backwards. So I need to avoid that. So if combination is in dead end or or combination in scene, then we would continue, and then afterwards we would add it into scene. Let's make a tuple. So because it's a set, and you need a tuple to add it in. So
Yeah, this is to avoid if you reach the same state, right?
yes, because you try both forward and backwards, and you end up having the case where you're just looping down and looping up, looping down, looping up, and never reaching the same, never being able to reach the solution because the dead end stops it. Okay, I think this is good. I don't know if we have time for a dry run or not.
The condition over here, if target equals to digit and continue, it should not be here. And why is that? You try to figure out, but still over here there's this hint for you. You can pause the video and think through it why actually that condition should not be here. If that condition is added, then we may not get optimal solution, and in fact sometimes we may not get a solution even though there is a solution. Okay, so let's continue. Okay.
Yep.
So let's move to the next problem, right?
Sure.
Okay. So you are given a 0, 1 matrix. Okay. So this is the problem. Where are
Given a zero matrix and find the longest
where
non-consecutive one.
did I paste it somewhere else? Let me like wait. Give me.
No, I see it. I see it. Oh, you removed it.
Okay, okay. Just give. I think I pasted this entire along with question 2 as well. Yeah. So this is the problem.
Okay. Given a 0, 1 matrix, find the longest line of consecutive ones in the matrix. The line could be horizontal, vertical, diagonal, or anti-diagonal. Line. Okay. I see. Number of elements in the matrix do not exceed 10.
So can you see this example 3 you got by this one, and this one, right? They are making one line,
Yes.
right?
Yes.
But if you'll talk about this one and this one, they are also making line, but the length is 2. This one and this one is also making a line, but length 2. So you'll have
Right.
to find the longest one.
I see. And the longest in this case would be diagonal.
Yes.
And there's also anti-diagonal as well. Anti-diagonal as in if we have a 1 here and then we have a 1 here, then that will be the anti-diagonal. Then the longest will be 4.
Yes. With this, how come like this 4?
Oh, sorry. That's I thought I don't know why I thought there's one more row. I'm sorry. It will be 3. Sorry.
Yes. Yeah. With this one, and
Yeah.
this one.
Yes. Yeah. Yep. Yep. Okay. We can certainly break this problem down into finding the longest in vertical, horizontal, vertical, in diagonal, anti-diagonal individually, as in we would loop through our matrix and then just use use dynamic programming to see if what's the previous longest chain consecutive is, and then increment by 1 if the current one is 1. Otherwise, you just continue and reset it at 0. Then we would break this problem down into and it's the same for diagonal. Diagonal, you check whether your diagonal value has the chain, and anti-diagonal, you just need to iterate backwards from the end to the beginning, and so that we would be checking values we've seen for anti-diagonal. So in this case, we would have since it's only four separate configuration, it would be big O of m times n for m row and n columns.
Okay.
And the space complexity here would be m times n as well, because we need to have a separate matrix to contain the scene, the old value, the previous value.
Yeah.
I think that's the fastest I can think.
Yeah.
I can.
Yeah, looks good.
The time complexity wise.
Right. Yeah. Let's go ahead. Code it. It's only like you are iterating each element once. Yeah. That's the optimal solution. Yep.
Yeah. So okay. So I believe we can group vertical, horizontal, and diagonal together because but then you cannot group anti-diagonal because you have to read it backwards. So let's go through horizontal, vertical, and diagonal. And we need a new array. So we call it DP, which would have 3 values for C in range of column, and for row, for R in range R row. Let's see. Okay. Okay. So now I'm creating 3 times R times 3 times M times N matrix, which
Three,
the
three
3
times.
because 3 because there's 3 items here. It's a triplet. Each one represent the first 3 the horizontal, vertical, and diagonal. Because anti-diagonal have to be done backwards, so I am doing anti-diagonals afterwards.
Why do you think like it is required to be done afterwards? Let's say, for example, this one, right? When
Um,
you are at this point, you already must have processed this one, right?
let's see. Do I have to? That's true. Let me see if that's any
Hmm?
issue with that. That's true, actually. Um, right. Oh, that is true. I guess as long as I'm going down, then uh, I guess I don't actually have to done it in reverse. Okay. So now we will have a triplet here. Sorry, quadruplet here. So
Hmm?
for R in range row, for C in range of column. Okay, so for the first one, let's do horizontal. Horizontal is upward. I forgot which one's horizontal. Horizontal is on
Horizontal
the wait.
column, right?
Horizontal is looking at a column. Okay, okay. I always get confused with that.
No,
Okay,
column
column
is like
wise.
a particular row. Horizontal, that's what you're saying, right?
Oh yeah, yeah, yeah.
Yeah,
Okay.
yeah, this
Yeah.
row, right?
Column. So you look. So you look for the previous. So if so you need to make sure if the previous if C minus one is bigger than 0.
Hmm.
Otherwise, you cannot look back. If C minus one if C is bigger than 0, that means you can check for the previous. Then dp of C R and C 0 would be equal to dp R 0 C minus 1, sorry. 0 plus 1 if the current value is also 1. So
Hmm.
we would just actually we would just put the condition here. If matrix R C
Hmm.
if not matrix R C, then we just skip then we just skip it. So if the current value is 0, then we will skip it. Otherwise, it is the previous value increment by 1, and that's it. And then we would do the same with column. Sorry, row wise. Bigger than 0, then dp 1 is equal to dp of r minus 1, c 1, and plus 1. And then we would now do the diagonal. If c is bigger than 0 and r is also bigger than 0, then dp would be dp c and r and c of 2 is equal to r minus 1, c minus 1, and then 2 plus 1. And then we would also do the reverse for diagonal. Diagonal, you need to check the column, the column plus 1 and the row minus 1. So if C is less than length of column, Oh wait, no. Assuming I have column as a, let me define my column and row first. Length of matrix. And then length of matrix 0. Okay, so -1. So if the C is not the n, it's not the, if we're not at the last column, and R is bigger than 1. Yeah, bigger than 0. Sorry. Then we would do the same thing. And then DP would be the R-1, which is the previous row, but we want to look at the column, one column above, one column after. So column +1 and +1, and then we would return the max value of all of them. So let me see if there's this. Let's just keep track of the running max. So max length equals 0. For length in DP at R and C, max length is equal to max and max length and length. So we keep track of the running max length, and we return max length at the end. Let's see. So let me just quickly check if I got it. Yes.
Yeah. This section actually we can include, like, anyways we are calculating in these, right, if else blocks.
Yeah, well, I just iterated at the end.
Yeah, it's fine. Like, there are 4 elements only.
Yeah. So DPR and C, the length, and we keep track of max length. Okay, and let me make sure I got the edge cases correct. So if C is so the anti-diagonal, if C, if there is only, let's say in this case there is 4 columns, so not column, just call. So call would be 4, and call -1 would be 3, and if C is if C is 3 is still correct. So I just want to make sure it's just strictly bigger, so it will not overbound. 0, 1, 2, 3, 3. Oh wait. Did I see it at most 3? Oh, sorry. I do have to do a -1. Otherwise, it will go overbound. Yep. Okay. And R is bigger than 0, and 0, 1, 2, and then I made a miss 3 here. Okay. Should I do a dry run in this case?
Yeah, sure. That would really help.
Okay. So we would maybe just do a simple. Let's do use our current example. Actually, it would be pretty painful to do a dry run on these, on like stuff like this.
You can create like maybe like a smaller, like 2 cross 2. That also should be fine, right?
Yeah. Okay, so the anti-diagonal is the longest, so that's the okay. Oops. Okay, so that's our DP matrix. So row and column. So for first R equal to 0 and C equal to 0. Oh, I think I did. I think there is a mistake here. It should be +1 if I'm not wrong. But let's see if that's the case. Okay, so if r equals 0 and c equals 0, then you would then pretty much nothing happens, and the first column would be all zeros, even though the length should be 1 actually. Should all be 1. Now we move to the next. Now column 1. Now C will be 1, and if C is 1 and the current value, then we would now check the second column and the first row, and C is bigger than 0. So and the current value is also 1, so that we would now take 0, which is this one. So here, let me put an arrow here so it's clear. Now it would be the previous row +1. Previous is 0. Now we go to the next value, and R is 0, so we skip that. R is 0, so we skip that. We also skip that because C is R is also 0. Then we will skip this because R is also 0. R is still 0, so nothing happens.
Just before that, can you like see if there is only one element, right? Like this.
Yeah.
So how are you handling this?
We would, if there's only one element, then we will, and then everything will run through, and we will have a DP matrix of zeros, 0.
And then what about this one? So you'll be returning 1 over here. Is it that?
Yeah, so returning max length +1 because it would skip the first item.
And then it will return same if there is only 1 0, right?
Yes, that's true. Yes, I missed this error. So
And in fact, for this also, let's say there is only one row, only 1 1 and maybe 1. So anyways, like it's not going to. So how actually are you handling this?
yes, so this, if it is 1, then the current value should be either 1 or it has to be at least 1. So the way I would do that would be to let me see, to assign this row, assign when the current value is 1, then this matrix becomes all ones instead of zeros. So on my DP, I would just add a new condition. Actually, no, I will add it right here. So if the matrix at R and C is equal to 1, then DP at R and C would be equal to 1 and 1 and 1. So now I would my row would be all ones, and now the to make sure we have the longest previous +1, yeah, then that would solve the issue.
Yeah. So finish that dry run. What you are doing.
Oh, okay. So with this new update, then we will have all ones and no update. And on the next one, on this current on this column, we would since C is 1, so we would get the previous value and increment by 1, so it'll be 2 in this case. And everything else, since it's all 1, everything else becomes zero. Becomes one because we just skipped through them. Then we would go to the next row. And since this row would be one, so the first thing is we assign it all to one. And C is zero, so we skip that. And R is now one, so we would be incremented by one as previous value 1 plus 1, so it's 2.
Mm-hmm.
And now we go to the next value. C is zero. Skip that. And now we go to the last one, which is the anti-diagonal. So C is zero, which fits the first condition, and R is one, which also fits the second condition. So it will be the previous row, which is previous row, but the next column. So we would pull this value out and increment by one. So now we have two. And we also be keeping track of the running sum. And now this column is zero, so we skip that.
Okay.
And then it will return two.
Yeah.
Which makes sense.
Yeah. Okay.
Okay.
That's all we had. Yeah. So today, like I especially chose like some these problems were like a little difficult. First one also like kind of tricky. Yeah. So maybe like this was very tiring for you today, right? So,
A little bit, yeah.
but a lot of things like I found like really like those. First problem is you ask like different kind of possibilities, like what will happen like when we turn like 0 to 0 0, right? So so good questions asked. I really loved it, like the way you clarified the problem. You tried some brute force. I actually didn't get it, like what actually you were trying to do there, brute force. So, anyways, like, but you finally got the idea. Uh, and then I had to give one hint about like you have to figure out some way like the shortest path, right?
Yeah, the brute force does not work, by the way. Yeah.
Exactly.
So it's
And
not a correct brute force. So I realized that afterwards.
right. And one more hint I had to give is like where you were actually trying to figure out is how to avoid dead end. So that point of time I had to tell you like you are not required to hit the dead end. You are not required to avoid the dead end, but you just go ahead and then return if there is any dead end, right? And then you quickly got the idea. That was really great, like BFS approach. Complexity is fine. Code clean, like code actually was like really clean, and you did a dry run as well on your own. So overall it was great. And second problem also, like you got the problem at once, like without any kind of hint. So great problem solving skills. Little bit like for anti-diagonal you got little bit confused, right? You are not sure, like you are trying to process it later, right? But with that little hint is actually you got that. And
Yeah.
over here is like you did a dry run on your own. So you asked me like whether to do a dry run, so that was really great. Code actually you did a verification whether you are missing any kind of one edge case you are missing. So anyways, like that you sorted out. Maybe like while doing dry run you certainly would have sorted that out. So overall is you did really great. That's what I can say. Is if you'll see, if you'll go to the next page, I tried to create some kind of a graph for you, is these parameters. So yeah, so this is what is there is problem solving 9, because of the hint communication there is no problem. And but still somewhere you were I given 9 because at some point of time is like I was not clear, like you told brute force, but it was not clear like what exactly you wanted to do over there. Coding skills, you are like right, completely clean code, there is no problem. And coding and testing, you are verifying your code on your own, but maybe like one or two edge cases that you missed, for that is 9. So overall great performance. Obviously you will get a strong hire, there's no question on that.